Hi everyone. For this topic, we will discuss about the correlation and regression. Now, let's take a look some of the example here. Let's say we have a measure of relationship between two variables. For example, smoking is strongly related to the incidence of a cancer, meaning that the number of the cigarette you smoke, there are more possibility you will get a cancer. So they are positive, meaning that the higher number of smoking, the number of chance to have a cancer. So it become a one correlation. The second example, student achievement is correlated with their attitudes. It is a very logically correct example. The more positive students to the subjects, meaning that their achievement will become greater. And the price of the chicken varies with the seasons. And then the fourth one, higher salaries will enable the workforce to be more productive. This example, some of the example that we can relate between the correlation and also a regression. Now let's take a look what is talked about the scatter diagram. Scatter diagram indicating the presence of the linear relationship between x and y. What is x? What is y? X indicate as an independent variable and y is considered as a dependent variable. Let's say we recap back the previous example related with the students' attitudes and also students' performance. Now, we can indicate the concept of independent variables and dependent variable by using a cause and effect factor. Example, what is the cause and what is the effect? But we cannot say that this is the cause, this is effect. What to indicate the independent variable and dependent variable, we can use a mechanism of the cause and effect, such as the previous example regarding the attitude and also the performance, meaning that we can consider that attitude is the cause that will affect the student achievement in the future. So therefore, the student attitude is considered as independent variable and the student achievement is considered as a dependent variable. Another example that I given to you just now is about the number of the cigarette which is smoking with the chance they to get the cancer, meaning that we can see that the smoking is a cause and the chance to get a cancer is an effect. So in order to determine what is independent variable and dependent variable, we can use the mechanism of cause and effect, which is the number of the cigarette is considered as independent variable and chance to get a cancer as a dependent variable. Based on this variable, we can plot in a scatter diagrams. So we can see a four type of scatter diagram here. So if the correlation between the independent variable and dependent variable is a positive relationship, you can see at the first diagram here, okay, the positive relationship. Okay, so you can see at the first one, so it's slightly moving from the left to the right, going up. And then if a negative relationship, we can see at the second diagram here. So we can see that it started from the right and going up to the left, and the gradient indicates a gradient of the negative slope. And there are two examples we consider as a non-linear relationship, which is first one non-linear relationship you can see at the third diagram, and no linear relationship is considered as a fourth diagram. So you can see that it disperses everywhere for the third one. So therefore there is no relationship. Now, like I have said just now, in this topic is considered two type of tests, which is the first one, linear regression, and the second one is a correlation test. Let's take a look for the first one, which is a simple linear regression model. As an introduction, the simple linear regression model is a mathematical equation that describes the relationship between two or more variables. So what is the difference between regression and correlation? the second one. It established the relationship of the dependent variable and independent variable. And one thing about the regression, instead of it describe about the and he tell you about the relationship between two or more variable, it also we can do as a part of a predicting based on the regression equation model that been proposed based on the data. So you can see at this equation, which is y equal to alpha plus beta x plus epsilon. So where alpha is the y-intercept of the constant terms, beta is the regression coefficient or slope, or it can consider as a m in a general mathematics. Epsilon is the random error terms, y is the dependent variable, and x is the independent variable. Now, in order to determine, as I mentioned just now, regression is not only can tell you or can describe to you the correlation of the two variables or more, it also can do as a part of the prediction based on the regression model that being proposed. So therefore, regression analysis involves estimating unknown regression parameters, which is considered as consists alpha and beta. That is the rule of alpha and beta. Denotes the estimates alpha and beta as beta. Then the fitted line is given by y hat equal to alpha hat plus beta hat x. So this is the regression model. So where y hat is a predicted of the fitted value, okay, and alpha similar let's say just now is a y-intercept and beta is a gradient of the line. Now, how alpha and let's say residual of the least square method. How alpha and beta are estimated is by using a method of least squares. Thus, we need to know that the residual is essentially an error in the fit of the model. Since it is estimation or prediction, therefore it must be related with the sum of the error. Therefore, EI equal to YI minus y hat I, and not a small residual sign of a good fit. And therefore, if we get the lower residual, mean that our purpose of the model is good. Residual of the least square method. Alpha and beta are estimated in such a way that sum of the square of residual is a minimum. Residual sum of square is also known as the error sum of squares about the regression line, or called as SSE. We find to alpha hat and beta hat by minimizing SSE, which is sum of square error given below. So SSE is equal to summation of EI square, or equal to summation of YI minus Y hat I squares, and therefore is equal to summation YI minus A hat minus B beta hat XI squares. Based on our explanation just now, we can translate it to differentiating SSE with respect to alpha hat and beta hat, and lead us to following equation, which is, okay, delta SSE over delta alpha hat equal to minus 2 summation of YI minus alpha hat minus beta hat XI, and delta SSE over delta alpha hat minus negative 2 summation of YI minus A hat minus beta hat XI times with the XI. Based on these two equations, setting these two partial derivatives equal to 0 and rearranging terms will result in two normal equations. And this is the equation that we have here. Then, from all these equations, solving the two normal equations simultaneously, yet the formula of alpha hat and beta respectively as follows. So this is a general form of the regression model, which is alpha hat equal to y bar minus beta hat x bar, and beta hat is equal to Sxy over Sxx. What is Sxy? Sxy is equal to summation of xi yi minus summation of xi times with the summation of x over n, and for this Sxx is equal to summation of x square I minus summation of x square over n. And another sum square that we will use is Syy is equal to summation of y square I minus summation of y square over n. So meaning that for the regression analysis, we need to know how to determine. We will have a alpha hat equal to y bar minus beta hat x bar. In order to determine alpha and beta, we need to know how to determine xxy, sxx, and syy. So this is having a computed alpha hat and beta hat. The least square estimated of fitted regression line is then produced as in equation below. So y hat equal to alpha hat plus beta hat x, and the line minimize the sum of the square of vertical deviation from the points to the fitted line as shown below. So this is the example of the how it will work in this square estimates. So since I have explained to you all the formula involved with the regression analysis, let's take a look the example how we can use the regression in our problems. A study is done to investigate if statistics scores have some effects on students' CPA scores. The data below are the statistic final examination scores of 10 randomly selected students and their corresponding CPA or GPA scores. So we can see here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 students, randomly selected students, and it started with the score of 87 until 78, and the students' scores of GPA or CPA from 3.41, 3.15, 3.28, 2.46, 2.89, 2.73 until 3.34. So based on here, we can do a calculation because we want to determine what is Sxx, Sxy, and also Xyy in order to determine the alpha and beta hat. Therefore, it's given, the question is already given, summation of xi is equal to 743, summation of x squared is equal to 56161, summation of y is 32.1, summation of y squared is equal to 104.1362, and summation of xy is 2415.9. And the first question is find the mean of the x and y. B, obtain Sxx and Xy, hence compute beta hat. C, estimate alpha hat, hence write down the fitted regression equation of y and x. And lastly, predict a CPA score if the students get 65 in the statistics. So how we can solve the problems? Let's take a look. Since we already know what is the x bar of the students, so we need to determine what is the x bar of the sample. So x, the mean score of the x is equal to summation of x. We already know 743 over 10, so we got 74.3. And then y bar is equal to 3.21 when we divide 32.1 into 10. And then, so therefore, that is answered for the question A. For question B, the question asks what is the value of beta hat. So in order to determine the beta hat, we need to determine the Sxy over Sxx. So Sxx is equal to summation of x squared minus summation of x squared over n. Therefore, 56161 minus 743 squared over 10. So we will get 956.1. And then equal to, so at the end, so we will get so for xy, okay, summation of Sxy. Okay, I'm sorry, this is a typing error. So this is s x y. So s x y is equal to summation of xy minus summation of x times with the summation of y divided by n is equal to 2415.9 minus 743 times 32.1 over 10. So we will get 30.87. So from SXX and XXY, we divide the 30.87 divided by 956.1 in order to determine the beta hat. So we will get the beta hat is equal to 0.03229. Okay, and then for the C, we need to determine what is the estimate of alpha. Therefore, estimate of alpha is equal to alpha hat equal to y bar minus beta hat x. So we will get equal to 3.21 minus 0.03229 times 774.3 is equal to 0.8109. So the value of alpha hat is equal to 0.8109. And number D, hence, the fitted regression equation we can propose is equal to y bar is equal to 0.8109 plus 0.03229x. And since the question asks what if the student gets 65 in statistic, what is his or her predicted CPA? So based on the regression model that we have proposed, we just substitute the value of x with the value of 65. So therefore, y bar is equal to 0.8109, or the value of the predicted CPA is equal to 0.8109 plus 0.03229 times 65, and it is like equal to 2.91. So since I have discussed with you the previous example, so based on the previous example, please solve these problems. I give you around 10 minutes to do this question. You can pause this video if you want, in order to give you a time to do the problem. This is the answer for the quiz that I given just now. For A, y hat is equal to 17.5122 plus 0.8780x, and B is equal to a unit increase in x expected to result in 2.9869 unit decrease in y, and number 3 is equal to 116, y hat is equal to 116.1899 units. And the general form of the regression model for B, which is number 1, is equal to y hat is equal to 138.5916 minus 2.9869x. I hope you got the same answer with my answer. That's all. Thank you.